All right, so take a minute and write down your next system of inequalities. I'm going to go ahead and redraw a little coordinate plane here. Your inequalities are in slope-intercept form, so we don't need to do anything except graph them. Now, look at your first inequality. You guys don't like inequalities like that because you don't know where to start. Your y-intercept is 0. That's why you don't see it. I'm sure if I was to write it like this, you would be fine, but this is high school, and you guys need to know that when the number is not there, it's 0. So for the first line, my one of my points is here at 0, which we're going to have to do something with our tester. My slope is positive 3, so that's up 3 to the right 1. And because this is a regular inequality, it's going to take a dashed line, just like that. Okay? Now, here's what I mean by we got to do something with the tester. You cannot let the tester be 0, 0 if there's a line that passes right through it. So all you simply do is pick another tester. Now, it has to be the same tester for both inequalities. So whichever one you use for the first one, we have to use for the second one. So in my eyes, I'm like, okay, well, 0, 0 doesn't work. Then we'll just use 1, 1. Doesn't really matter. So if my tester is 1, 1, we're going to put it right here, right there, okay? And we're just going to check it. Don't have to worry about that. That's not even really supposed to be there. If x is 1, is y is 1, and I'll just put here so you can tell that we changed it. We write it down just in case so you can be, accurate. If x is 1 and y is 1, you're simply asking yourself, is 1 less than 3? Is that a true inequality? Why, yes, it is. So if 1 is less than 3, that means that my tester is part of the solution. So we are going to shade below that first boundary line. Okay, so you shade below it. And you're ready to go to the next one. Now your next one, this is what you used to. Your y-intercept is positive 1, so we're starting right here at positive 1. Your slope is negative 2, so we're going to go down 2 to the right 1, and there's our 2 points. This is an equal to, so my inequality is now a solid boundary line, and I still keep that same tester right here, still have that same tester, and so we're going to check to see if our tester is true or false. Now, it's still 1, 1, so now I want to know, is 1 greater than or equal to everything on this right-hand side? Well, if my x is 1 and my y is 1, I got a little work to do on this left-hand side. So that's going to be negative 2 times 1 plus 1. Well, I have 1 greater than or equal to negative 2 plus 1. Negative 2 plus 1 is negative 1. So I need to know, is 1 greater than or equal to negative 1? It is. This is a true statement. So when you look at your orange line, I need to include the part of the line with the tester. So I'm all on the right side. And then where you see right here where the two colors merge, that's your solution. That's your solution. All right, we're going to do, I think you got 2 more.